Hi guys, welcome to week 12 of Digital Electronic Circuits live session. This is the last week and today we will be discussing some questions that may help you in your exams, which will be based on week 12 assignments. So let us begin. So this week we have questions on mostly on memories. So we will see how to solve those questions. Generally these questions are very easy, so I hope you will follow and score well from this part at least. So first question is in DRAM, if periodic, so we have to select which is correct. So in DRAM, periodic refreshing is not required. Information stored in a capacitor, information stored in a latch. Both read and write operations can be performed simultaneously. Uh, would anyone like to answer this? So by now you must have gone through 2 more live sessions and the video lectures also. So okay, so what is DRAM? So DRAM is a very simple. It has one transistor and one capacitor. So it is also called 1T 1C cell. So here the information is stored in capacitor, and since capacitor can discharge, periodic refreshing is required. Information stored in capacitor, if I stored as latch is incorrect, was read and correct one, this is also incorrect. At a time you can only put one read or write in any memory. So the correct option is B. This is DRAM. Okay. Are there any doubts in this question? Okay, let us move on to the next one. A 16 KB, that is this many bits memory array is to be designed as a square with an aspect ratio of 1. So this is the aspect ratio of 1. As number of rows is equal to number of columns. Minimum number of address lines needed for the row decoder is. Okay. So first of all, what the question says, we have a square memory, let's say n cross n, and given n cross n is 16 KB. It is 6384 bits, right? So the number of address lines, this is n. The number of address lines needed is log base 2 n, right? Address line will be needed from here. So for that, first we need to figure out what is n. So n will be under root 16384, which is 128. Okay, and this is also equal to 2 to the power 7. So number of address lines equals to 2 to the power log 2 128, so log 2 to the power 7, that is 7. Is clear? So number of address lines, if you have, let's say, x number of rows then number of address lines needed equals to log base 2 x. So to see this again, let me know if there is any doubt. So let's see the next question. Each cell of a static random access memory contains. So please take a few minutes to answer this. If you know the answer, please type it in chat or you can speak using the mic. Okay, let us see this. So what is static random access memory is SRAM. So SRAM is the fastest memory in CPU. It is used as cache memory and it is volatile. So every time you uh, restart an operation, the SRAM will lose its contents. So it is located very near the CPU. It is located, cache is very near in the CPU. So uh, it is very fast and it is there to just give and take data between the CPU very fast. And so it is made using CMOS inverters. So in SRAM we have two cross-coupled inverters, right? So it is a memory storing element So if you give let's say 0 here, this will invert it to 1, and if you and this 1 will go again here to 0. So at this node it will always remain 0, at this node it will always remain 1, right? So again, now to access this memory, we connect to the transistors. So these are the two access transistors which are there to for read and write operations, and it is connected to bit line and word line. So how many transistors do we have? So in an inverter, we know there are two transistors, right? So how many transistors we have total? 1, 2, 3, 4, 5, and 6. This yeah, total 6 transistors. So it is also called 60 as RAM. So it is found in cache memory, and since it is RAM, so you have also seen DRAM in the first question, right? So DRAM is the RAM that you like your systems have, right? 4 GB, 8 GB, 16 GB. That stick RAM is DRAM, and SRAM is static RAM, that is cache memory. It is very fast than DRAM. So I hope it is clear.
Yes, sir.
Okay, so the minimum number of MOS transfer required to make a dynamic RAM cell is, so this we had seen earlier, we just need one transistor and one capacitor, right? So it is one, right? Next question, a PLA can be used as, okay, let me answer this question first. So PLA is what? Programmable logic array. So it is a crossbar of and OR gates. So basically it is used for realizing any combinational logic. Sequential logic we cannot make because it requires clock, and dynamic memory. So this is what that it's just to realize combinational logic. Now, Jagannath, you're asking what are the important topics? Okay, so I what I feel the important topics are, first of all is uh, flip flops and circuits. Second is sequential circuits, which is like counter, etc. Machines. Third, we also have we have very little introduction to DACs, digital analog converters, and fourth, we could have uh, K-map, Boolean algebra. So what I feel is these are the most important topics that you should prepare well, that can help you with your exams. And I expect the questions should be uh, like your assignments. So go through your assignments well and uh, try to yeah, just solve your assignments and see similar kind of questions. Okay, okay, so question is DRAM consists of 1T, 1C. This we have already seen. Let us move on to the next one. We choose the correct statement from the following. PROM constrains a programmable and then fixed OR. PLA constrains a fixed and then programmable OR. PROM constrains a fixed and then programmable OR. PLA constrains programmable and then programmable OR. Okay. Please try to see this question. Can we discuss two questions of DAC? Okay, sure. Okay, so let us first solve this question. PLA contains fixed and then programmable OR. So, so this is correct and this is correct. So PLA actually contains programmable and programmable OR. Both are programmable. And PROM constrains fixed and programmable OR. And there's another thing is PAL constrains fixed or programmable and great. So these two are correct options. Jagannath, what questions do you want to discuss? You can ask them right now if you want. Jagannath, any questions from DAC? Okay, so let me see. DAC we did last week. So I would request you to go through this last week's video lecture, but I'll try to reiterate some question. So this is a good question. Successive approximation type ester ADC. Okay, one DAC, this is ADC. So let us solve this one. Okay, so sorry, for any DAC, V out is resolution into V in. Now this resolution varies depending on, it is always, resolution is always Vref, that is a reference voltage given to the DAC, divided by 2 to the power n or 2 to the power n minus 1 depending on the type. So R2R, it is a binary ladder. So interesting. So these are very basic. So interesting question that I find in DAC is this one. Yeah, this one. Successive approximation type ADC. So let us try to do this question. Let me copy this page. So I'll use it first. So the question is, you have a 7-bit successive approximation type register type ADC used to convert this voltage to the digital output. The reference voltage is 10 volts. The output of ADC can start at 5th clock pulse at the start of conversion. Okay. So you see the first thing is what they are saying. So what happens in a successive approximation type? So we also call it SAR ADC. What happens is you approximate in each clock cycle, right, until you are close to what you want. Okay, so uh, so here reference voltage is 10 volt and number of bits is 7. So your resolution is to 10 upon to the power 7, that is equal to, sorry, 7 minus 1, it is 10 upon 127 is what, I'm just copying the value, 0.0787. So first step is you found the resolution. Okay, so next what you have to do is, so what it says, it is a 7-bit ADC, and how it will start, it will start with all 7 bits are 0, 2, 3, 4, 5, 6, 7 is initial. Now in the first block, so okay, so for it, if this is MSB, this is LSB, and what you have to find is you have to convert 8.95. You have 8 point to convert 8.95. So what you will do is, okay, you start with MSB and change its bit to 1, 1, 0, 0, 0, 0, 0, 0. Okay, so now what this is, I think this is how much? 64. This is 64. Now this represents 64 in decimal. Now how much voltage will it correspond? That is, we multiplied with resolution, that is 0.0787, right? So it will correspond to how many volts? 5.03. 5.03. Now this 5.03 is less than 8.95. So what we will do is we will keep this one, keep the bit. So okay, so what we will be successfully doing here is we will have two options. Let's say after every substitution, if this is the number x, if x is greater than 8.95, if x is less than 8.95, keep the one, discard the one. This is the process that we will repeat. Since it is less than, we will, sorry, wait a minute, opposite. If it is less than, then we keep the one, is greater than, we discard the one. Since it is less than, we keep this one. So next on the second cycle, we have this one. Now we change the second bit to 1. Right, so we change to 1, 0, 0, 0, 0, 0. Now this corresponds to I think 96. This corresponds to 96 in binary into resolution 0.0787, and it is how much volts? It is 7559. 7.559. Now this is our x, and it is again less than 8.95. So we again keep this one. Okay, so we go to third cycle, third clock. We have 1, 1. Now we change this third one to 1. 0, 0, 0, 0. Now this is how much? 112. 112 base 10 into resolution 0.0787 is how many volts? These are all in volts. We are comparing the voltages. This will give me 8.818, 8.818, which is less than 8.95 again. So again we keep this one. Now we can go to fourth clock. So we keep these three, then we change the fourth one to 1, 0, 0, 0. Now it is 120 base 10 into 0.0787. We get 9.44, which is less than 8.95. So we discard the one. So we discard this one, and we finally get 111, 0, 0, 0, 0. So in the fifth cycle, I have discarded this one. So I'll just, what my next step would have been 111, 0, 1, 0, 0. I would convert it to binary, multiply it to resolution, then check if it is less than or greater than 8.95. Okay, so question had asked at the start of fifth clock pulse. So at the start of fifth clock pulse, I have uh, this, right? This, I have this. So this is my answer. Did you follow this question? Do you have any doubts in this? Okay, let me see if I have another question that we can do. So these are mostly theoretical and simple questions. So if you see another question, this in an R2R ladder DAC, input is 111011, reference voltage is 20, what is the output voltage? So I already told you V out is Vref upon 2 to the power n into V in, right? So you just have to put these values. This V in 101 corresponds to 11 volts. So Vref is 20 upon 2 to the power n. N is the number of bits. We have 4 bits. So 2 to the power n into 11. So if I solve, I'll get this 13.57 volts is as V out. Okay, 2n minus 1, I think we put in first part. Okay, so thing is, where do you put 2 to the power n? Where do you put 2 to the power n minus 1? So in R2R ladder, we use 2 to the power n. Rest all other 2 to the power n minus 1. Okay, just remember this. If it is written ladder R2R, you use 2 to the power n. Rest all other types, if it is a SAR or any other anything else, just use 2 to the power n minus 1. Okay. Okay, so these are similar questions. So yeah, you can go through them in the last week's lecture also. Let us get back to our original lecture. Okay, so let's solve this one. Let us reiterate. PAL fixed and programmable and PROM fixed and programmable or, and PLA programmable and programmable or, both programmable PLA. Okay, so let us see next question. So this was from the assignment. In the given circuit, if the control logic inputs are CS dash is 1 and RW dash is 1, which operation will take place? Please look at it and let me know. So it is a very simple question. You just have to look at the inputs. So what you have, so let us draw a truth table.
Hello, can you hear me, sir? Am I audible?
Yes, yes.
Sir, this exam is in this week, sir. Can I know what are the questions can we expect for this question for this exam?
Okay, so I
Okay,
just
so I
told
just told
earlier. So
earlier.
these are
So
some of
these
the
are some of the
important topics
important topics. Okay.
that you should
That you
focus
should
more.
focus more.
Flip-flop
Okay.
and
Flip-flops
related
and
circuit,
related circuit,
sequential
sequential
circuits,
circuits,
counters, and
counters, and
state machines,
state machines. Okay.
and
And
ADC,
ADC,
DSC,
DSC,
and
and
key map
key
Boolean
map
algebra.
Boolean algebra. Yes, sir.
So these
So
are
these are
pretty important
pretty
topic, and
important topic, and
uh,
uh,
I expect the
I
questions to
expect the
be very
questions to
similar
be
to
very
your
similar to
assignment.
your assignment.
So
So
just look at your
just
assignments
look at your
before going
assignments
to exam.
before going to exam.
So
Yes, sir.
that
So
would help you a
that
lot.
would help you a lot. Okay. Then what about is there any miscellaneous examples like other than the assignments questions, sir?
Currently, I do not have
Currently, I
them,
do
but
not have
maybe
them.
you can go
Maybe you
through
can go through
the live
the live
the notes in the
the
live
notes in the
notes of
live
the live
notes of the
of the
live
live session,
session.
because we
Okay.
often
Because
pick
we often
some
pick some
questions that are just
questions
from
that are just
internet,
from internet,
so it would
so
build
it
a
would
question
build
bank
a
for you.
question bank for you. Okay. Do we get any question banks from your side, sir, other than the assignments?
Uh,
Uh,
Currently, I have not
Currently, I
prepared
have
any,
not prepared any,
but if you
but
need,
if you need,
you can look
you
at.
can look at.
Wait, your voice is
Your
echoing.
voice is equal.
Just a second.
Just a second. No, I guess your
Okay.
voice is pretty good, sir. Like it is okay.
Actually, it is
Actually,
echoing
it is
from
echoing from
your
from my
mic.
side, sir. From my side.
Okay. Anyway,
Okay.
so
Anyway,
for
so
question
for
bank,
question
so what
bank,
we
so
usually do
what
is
we
we
usually
just
do is we just
look at previous
look
year
at
gate
previous year
questions
gate questions
related to
related
these
to
topics,
these
and that
topics,
should
and
be
that
more
should
than
be
enough
more than enough.
for your
Okay. For
practice.
your practice. Yes, sir. Yeah. Then thank you, sir. That's all from my mind. Yeah.
Okay. So these questions that I have put in the starting are also from previous year gate questions only. So these are pretty very simple, but yeah, that is how you should expect these type of questions. Okay, let us get back to this question. Okay, so we have two inputs, CS bar and R slash W bar. When we have two outputs, write or read. So it is asked if CS bar is 1 and RW bar is 1, then what will be the output, read or write? So for this, we can, it is simple to look at. So if CS bar is 1, that means uh, this will not work, and if it is 1, then read will happen. So answer would be read. But let us see how it goes. So just make the trip table 0 0 0 1 1 0 1 1. So what does CS bar means? If anything has a bar, that means it is active low. So or you see the output of CS bar is right, right? So this, yeah. So output of CS bar is right. So whenever it is 0, right will happen. I can look at from this also as W bar. So whenever you get 0, write will happen. Whenever you get 1, read will happen. So here write will happen because CS bar will also output write. So write will happen, read will not happen. Again write will happen and read will also happen. Here only read will happen, write will not happen. The write will not happen. So write. Okay. So our concern was this 1 1 case. So read will happen, write will not happen. Okay, so I'll repeat this once more. So let's make it simpler. So instead of CS bar, I'll write it as W bar only because our output is right. W bar R slash W bar. Now it will be clear. Read or write 0 0 0 1 1 0 1 1. If this is 0, write will happen. This is also 0, write will happen. So write will happen, read will not happen. Let me write read as 0. This is 0, write will definitely happen. This is 1, read will also happen. This is 1, write will not happen, but this is 0, so this will enable write. Write will happen. This is 1, write will not happen. This is 1, read will happen. So read will happen, write will not happen. Which was 1 answer. So read will not happen. Go to this keyword. Let us move on to the next one. How many data input and address lines are required for 128 cross 16? Okay, let's try to solve it if you can. Then we'll do it. So did anyone get any answer? Okay. So anyway, so let us try this. So we have 128 cross 16, 128k cross 16. Okay, so okay, so what does this mean? 128k is 2 to the power 7 and k means 2 to the power 10. So this 128 2 to the power 7, k is 2 to the power 10. So this total is 2 to the power 17 cross 16. So what it means? So the memory that we have, it has 2 to the power 17 rows and 16 columns. 16. This is 2 to the power 17. Okay. So how would you load the data in this memory? What you would do? Let's say you want to load in row number 5, right? So what you would do, first you will select row 5, then load 16 bits. So from here you will load all 16 bits all together. So 16 bits is the word length of this memory. So at a time you can load 16 bits. So now the question is, how many data inputs that you have? Data inputs is, so this is the number of data inputs, 16. So you can input 16 data at a time. The data input is 16, and number of address lines that we have seen in earlier question also. So if you have 2 to the power 17 rows, then number of how many uh, what would be the decoder size, or how many address lines would I need in a decoder to uh, access the 2 to the power 17 rows? So that is log base 2 into 2 to the power 17, that is 17 address lines. Right? So what we are doing is, say we will have a decoder. It will have 17 inputs, A0 to A16, and it can access all these 2 to the power 17 rows at a time. Right? So this decoder will select the row that we want to select, want to load, and then once this row 5 is selected, we will input 16 bits in it at a time. Okay, so data input is 16 and this input lines are 17. So it should be 16 comma 17. Please look at it once again and let me know if there is any doubt. next question. It's pretty simple. So just give it a thought how to solve it. So you have 1M cross 4 memory and 64K cross 4 memory. How many of these required? You just, very simple, just divide it. So it will be 1M cross 4 divided by 64K cross 4. So 4 you cancel out first. That's fine. So 1M upon 64K. So 1M is actually 2 to the power 10K. 164K. So it gives 1024K 164K. K cancel. It will be 1024 upon 64, which is 16. 16 is the required answer. So 16 number of 64K cross 4 memory can make 1M cross 4 memory. I hope it is clear. Let us see the next question. In the given circuit, PLA, the expression F1 and F2 is given by. So let me edit this is cross. So these are and so in one we have what is this C bar, this is A bar, one is C bar A bar. Second we are going C B A, to say ABC or this ABC. And third we have C bar and B bar, B bar C bar. So we have another. And fourth we have AC, right? And in this or one we have 1 plus 2 plus 3, that is A bar C bar plus ABC plus B bar C bar. In R2 we have 2 plus 4, that is ABC plus AC. So here it is F2 is 0 XOR this one. So X will be X, and F1 is 1 XOR F will be X bar. So F2 will be A bar C bar plus ABC plus B bar C bar. F1 will be ABC plus AC whole bar. So if you solve the K-map for this, you will get this first option, midterm 0, 1, 2, 3, 4, or you can just expand it. Question number 5 from Week 1, question number 2 from Week 3. You can see if I have this. Okay, so I'll see your questions at the last because I think I do not have them on my iPad. I'll look for them on the NPTEL website. Then we can solve it. Okay, Jagannath. You can stay back after the session. It's over and we'll see. Okay. So this question is done. Next question is, which of the following statements is are true? The main memory of a computer system must be non-volatile. The data memory can be built using ROM or RAM. This false. Use RAM, which is volatile. Data memory ROM or RAM. False. RAM only. Sorry. Meaning ROM is read only. We need both read and write. So this is false. Write enable time is and time not this is also false. SM is a simple yes, this is true. So only fourth is true. Jagannath, I'll be here only in this video, in this link. So I'll just finish all these questions first for today, then we will solve your doubts. Okay. Suppose you are using linear addressing in memory, it has these many bits. You are reading and also matrix addressing memory total number of input pins. That is decoded by the both linear and matrix addressing are. Okay, so we have for linear addressing number of input to be decoded special log to 1024, that is 10. For matrix, number of input to decoder is half of that, which is 10 by 2 equals to 5. And column decoder is also 5. So total is 10 again. So answer is 10 and 10. So both for linear and matrix decoding we need 10 and 10. Next. Okay. So you need a word organized separate input output memory, which IC is suitable. So IC 2114, it is word organized, but it is common input output. And IC 2115, it is bit organized, but it is separate IO memory. So we need word organized plus separate. So this is word organized only, this is separate, but there is no IC which has both of these. So it is none of them is suitable. These are all theoretical and easy questions, so I am going through them faster. you have doubt, please feel free to stop me. I don't think these are important, these theoretical ones. The logical ones that you have to solve actually to get an answer are more important. Okay. So in the following 3D configuration of DRAM cell, you need to first write a single binary digit 1, then read from terminal Y. Assume the parasitic capacitor discharge follows operation, what is the correct capacitor? Write is W, R and Y terminals. Okay. So if you are they're saying you feed 1 here, that is you are uh, giving D in. This is V, this is R, this is Y, this is Y. So to write this, so this capacitor is empty, right, discharged. So to store this one, what you would need to do, you will turn on this transfer. So this one will store here, this capacitor will charge. So to do that, you need to change W to 1, then V will change from 0 to 1. Right? If this is charge, initially it was 0, now after charging it will go to 1. Right? Now, now this, if this is 1, this gate is turned on. So, so it is like your this ground is now shorted here. Now to pass this ground here, you need to turn on this R is 1, then Y will go to 0, which is the read condition. So you read this. So for this W is 1, R is 1 and Y is 0. So let's skip this question. Let's see this. Which of the following statements are true? EEPROM uses UV light to quartz into 3 rays. No. EEPROM is electrically erasable, programmable. No. So it is electrically visible, not you don't need UV light. So this is false. In PLA, AND is fixed or array is programmable. So this is false. In PLA, both and or programmable. In PL, or is fixed and is programmable. So in PAL, we will have this is 2, I think. And in DRAM have higher package density than SRAM, that is true, because in DRAM we just have one transistor or one capacitor. In SRAM, we have 6 transistors. So obviously this is smaller, so have higher packaging density. So next question. Which of the following statements is true? In a random access memory, the access time depends on location of the word. This is false. In a random access, the access time independent of location of the word. This is true. In sequential access memory, the access time independent. False. Access time is the same for a location in both random, which is also false. So in random access, that means you can access any location at any time, right? So it should take uh, random access uh, access time independent of location. In sequential access time is a function of location. Since sequential means you're like accessing bit by bit, going here, then here, then here, then here. It is in a sequence. That means if you want to access this last one, it will take you a lot of time. So only B is true. SRAM memory offers high density, low cost, high speed, low power consumption. So it is high speed. So higher density was DRAM, right? Low cost was also DRAM. Low power consumption was also DRAM. A memory unit 1024 is specified the number of word times the number of bits, how many address lines. Okay. Again, I told you earlier, so number of address lines equals to log base 2 into 1024. That is 10. So it is like you have 1024 cross here, cross 64 here. So here you need a decoder that has 10 inputs, and 1024 outputs to access each row. then you can feed 64-bit data at a time in each row. Okay, so last question for today then. This is C bar, B bar, A bar. So this kind of question we have already solved earlier. This PLA, just call it 1, 2, 3, 4. So in the AND 1 we have this and this. So it's B bar C bar. In 2 we have this and this, that is B bar, which is actually 0. In 3 we have A bar, B, C bar. In 4 we have A, B, C, right? And then OR the C. Just OR X, Y, Z. In X we have 1 and 3. 1 plus 3, that is B bar C bar plus A bar B bar C bar. In Y we have 2 and 4. 2 plus 4, that is 0 plus ABC. In Z we have 1, 2 and 4 plus B. 1 plus 2 plus 4, that is B bar C bar plus B, that is 0 plus ABC. Okay. And X equal to F3, Y equal to F2, and Z equal to F1. So what does dot means? Okay, good question. So dot means just this is shorted, right? So here you see C is coming from here in this whole line, and C bar is coming here in this whole line. And if we are looking at this AND gate 1, so it is shorted at this C bar, right? So that means one of the input to the AND gate is C bar. So one of the input is C bar, and another input here is shorted here, right? In this line it is B bar line. So another input is B bar. That is why I wrote this output as B bar C bar, right? So it is B bar C bar is the output of the first AND gate. That is what I'm writing. These are the outputs of the one AND gates 1, 2, 3, and 4 based on these connections. Okay. Similarly here, once these are the outputs of the AND gates, right? These 4 AND gates. Now these outputs of the 4 AND gates are connected to OR gates. So let's say in OR gate Y, we have the output of second and fourth. So second was B bar plus fourth was ABC. So second and fourth are odd. That is why we get 2 plus 4. Second and fourth, that is B bar is 0. Fourth is ABC. This. So dots are just connection. Is it clear? I hope it is clear. If not, please do ask again. So we have F1 is ABC plus B bar C bar. F2 is ABC. F3 is B bar C bar plus A bar B bar C bar. So F1 is ABC plus ABC bar. Second option is correct. Is this question clear? Okay. So I hope it is clear now. Let us look at some of the questions you were asking. You were asking in week 1 and question from week 1 and 2. So let me check question from week 1 and 2. Just a minute. So I think you were asking this one, right? Question number 2 from week 3. Is this correct? Okay. So what this question asks is, what in case of question mark will make this function a self-dual? Okay. So I have written what is self-dual. So for self-duality, there must not be two complementing terms. So what does that mean, complementing term? Let's say it has m1, 2, 4 and something question mark. So let us leave the question mark for now. Let us focus on m1. So m1 means it is 0, 0, 1. M2 is 0, 1, 0. M4 is 1, 0, 0. Right? Just simply 1, 2 and 4 in decimal. Right? Now this their complement is, if it is 0, 0, 1, if I take complement of each term, it will be 1, 1, 0. Right? And complement of 0, 1, 0 is 1, 0, 1. The complement of 100 is 0, 1, 1. Just complementing each digit, right? Its complement is 0, its complement is 0's complement is 1, 0's complement is 1. So that means there must not be two complementing terms. That means if I have these three terms, I must not have these three terms. These three must not be there as a question mark. Else it will not be self-dual. For self-dual, there should not be two complementing terms, right? These are complementing terms, these are complementing terms, and these two are complementing terms. So we had these three initially and we removed their complements. What are their complements? This is the complement, this is the complement, this is the complement. Now the remaining two terms are only 0, 0, 0, that is 0, m0 and 1, 1, 1, that is m7. So it can be either 0 or 7, and this is in option it is 0. I have written 0. If there would have been 7, then we would have ticked 7. Is this question clear?
Yes, sir.
So question 10, right? Let me see. That is question 10. In this was question 10. So suppose you need to formulate the functionality of a light meter sensor. Indicates bad light condition depending on the measurement of several environmental attributes. The sensor is manufactured as a black box. Okay. However, the sensor you can find four controllers, 1, 2, 3, 4. Okay. The sensor output TP1, that is LED. Okay. Assume green is 1 on, red is off. Okay. Suppose you already tried different on-off conditional controls in the input mentioned below. Find the midterm expression corresponding to Boolean light meters output. Okay. So it simply means that uh, you have four inputs, these four switches, switch 1, 2, 3, and 4, and you have one LED output. So for different combinations of on and off of these switches, you have yeah, for these different combinations you have either light off, that is 0, or turning on, that is 1. Right, so this is the given table. Now they are asking just simplified expression for this TP1. So this you can, so it is 1 only when only these four conditions, 6, 7, 14, 15. So it is function is sigma n 6, 7, 14, 15, right? And if you solve it using K-map, so 6, 7, 14, and 15, you get this quad, which is, if I write it as, it is BC, and B was switch 2 and C was switch 3. So it is switch 2 into switch 3. That is the answer. Now, do you understand what we have to do in this question? Sorry, I could not hear you.
Yes, sir.
So it is just simply asking you to solve this for this function using K-map. It's as simple as that. Just a very lengthy question. Okay. From week 3, let me see. Week 3. So question number 3 from week 3. Let me just see what is the question. Just first question. I think this is the question. Question 3 of week 3. Okay. Find the total cost using multiple output minimization. Okay. So, okay, so what does it mean is that you have two functions, f1 and f2. So what you want to do, you want to find the minimum number of gates required to implement these f1 and f2 together. You want to find minimum number of gates. That is the minimum or minimum total cost, right? So for that, what you need to do is first draw the k-map for both the functions, and then you want to implement f1 and f2 together. That is, we have to find the common terms between f1 and f2 which you can share in these two circuits. So what it means is that, so if you look at, we draw k-map for f1 and k-map for f2, right? So f1 was this 0 1 this, and f2 was this. So what we did was we made some pairs. Okay. So in f1 we have these two quads and one pair here. In f2 we have this, this, and this. Okay, so now let us see if there are any common terms. Okay, so if you see, this part and this part is common in both, and this part is common in both, right? So I have written those. So we have written f1 b c bar d. This is b c bar d. This is also b c bar d. So b c bar d is common in both f1 and f2, and there is acd. Oh, sorry, acd bar. Acd bar is this, which is both common in f1 and f2. So in the expression of f1 and f2, now we have two terms that are common, right? So okay, so now the number of that the cost that we will get. Okay, so for uh, each literal that I have here, there will be one cost. So I have 1 2 3 4 5 6 7 8 9, right? So I have 9 from here plus, and three terms, 2 1 2 3, three terms. And here in f2 I have one. Okay, yeah. So what we are doing is, here is, now we are, now once we have written the, sorry, once we have written the expression for both which have maximum number of common terms, right? So two terms are common here and two terms are common here. So I am counting the number of literals. Number of literals means number of letters that I have. 1 2 3 4 5 6 7 8 9. So I need these 9 letters to make it. Then the total number of terms, that is 1 2 and 3. It has 9 literals plus 3 terms, right? It has 9 plus 3, that is 12. Right? 12 is the cost for implementing f1. Now if you look at f2, we have 1 2 3, these three uh, these three literals, a b bar c bar, and these are already common. These are already implemented here. So we won't need to count 4 5 6 7 8 9 of this, because we are using it common. We just need two more gates, right? So we will have three terms here and three later, 1 2 3. So it is 3 plus 3. Cost is, general cost is, f for f2 is 6. It is 3 plus 3. 3 literals, 1 2 3 plus 3 terms. It is 3 plus 3. So that is what I have written here. General cost is 12. That was 9 plus 3 for f1, and 6, that is 3 plus 3. That is 18 total, right? And total cost is this g plus number of gates. So if you see the number of gates, we need one gate, and gate 2 3 4. We need four AND gates plus, so I've implemented it here. We need 1 2 3 4. 5, 6 gates. So 18 plus 6, that is 24 is the cost, total cost. Is it getting clear?
This is clear, sir. So question 2, please.
Question.
Question 2 is provide the minimized SOP expression of the Boolean of the following map variable.
Is it this one?
There is a K map given in the question.
Let me see. I think I have not solved it. So let me see. Question is, we have the K map. A bar A, B bar C bar, B bar C, B C bar, B C, B C bar. We have D plus D, E bar 1, cross cross 0, E. Okay.
D dot E. D dot E in my question.
Sorry,
D plus E.
it was D dot E.
Instead of D plus E, yes.
Okay, let's solve it for D plus E because I have D plus E. So we'll see later what will happen with D dot E. Okay. So what we have to do is we have to form the pairs. So one could be this, another could be this, and another could be this. Right. So if it is asking in POS form, right? So in POS we choose everything except one. Don't choose one. Right. Okay. So now it is what we have here. So one is to nothing else. This is POS form. So in POS we write A, this is A bar, P B plus C, B plus C bar, B bar plus C bar, and B bar plus C. So if you look at this quad, all the common terms are D plus E plus D plus B, where B is common, B is common, right? So this quad will give me B plus D plus E. Okay, then I have this E. This will give me A bar plus E, and I have this one. This will give me B bar plus C bar plus E bar, and what else is there? Okay, so let us see the terms that we have currently. B plus D plus E, A bar plus E, B bar plus C bar plus E bar. Okay, so there is one more term in the options, so that is B C bar D plus another is there forming this, so it will be B plus C bar plus D plus E. So all these four terms are in option C in my question. So what they are doing is, okay, so your question says SOP or POS, can you tell me?
Sir, mine was SOP.
SOP. So in SOP, okay, can you tell me the SOP one? Let us try SOP one. A bar A, B bar C bar, B bar C, B C, B C bar. Okay, what are the entries?
D dot E,
D dot E.
D.
Sorry, D. Sorry, can you repeat?
Sir, first one D dot E,
D dot E.
then D,
uh,
E bar,
E bar.
1.
Okay,
Then don't care.
don't care.
Then, sir, again don't care.
Mhm.
Then nothing. Then E.
Okay, now they're asking SOP. So now how will we make there is one could be this, another could be this, and one more could be this. Okay, let us see what all these pairs could represent. If you see, look at this one, it would be D dot E dot B bar, B bar dot E dot E, right? And if you look at this one, it would be A bar. This one would be B C bar E. Then what are the options? Can you share the option? Maybe can you share your screen if possible? Are these coming in any of these three terms coming in any of the options? Uh, can you zoom in a little bit? Okay. So, let's is option A is correct. B bar D, B bar C D. Okay. A bar B bar D bar B bar. Okay. B C bar B C bar. Okay. Now you can close your screen share and I'll share. Let me share. Just okay. So how they are formed pairs is use this color. This is one. I think this is another. This is one and this is one. So this is B bar C bar D E. This is B bar C D. This is A bar B E bar. And this is B C bar E. So your SOP answer is just sum of all this. B bar C bar D E plus B bar C D plus A bar B E bar plus B C bar E. Solution.
Sir, why you put D, B bar, C bar, and D, E?
Okay, so in this what you will do is, so let's say if it was not D, it was just one, right? Then you would have formed this and you would have named it as B bar C bar only, right? If it was one instead of D.
Yes, sir.
Now if it is simply written, let's say it is something X or Y is written, so you just multiply it. If it's X written, then it will be B bar C bar X. By default, if you are naming it B bar C bar, that means it just multiplied with one.
Sir, why
You
it
will,
is multiplying, but generally in K-map form, there
yeah,
is no such method.
no. Okay, so how you arrive at this? These are what you write here is just the outputs, right? If from a truth table,
Yes, sir.
you just write if it is A, B, C dependent, you just write if Y is there, you just write 1 0 1 0 whatever it is. You write those ones and zeros here, right?
Okay,
Let's
sir.
say it was not 1 or 0 in the output Y, it was let's say some other variable E or F. Then you would write E and F here, whatever it is. And then instead of just forming pairs and naming it as B bar C bar, you will multiply whatever you are encircling also. If it has D and E inside, you will multiply D and E in this. Is it getting clear?
Yes, sir.
Let's say, and I'll give you an example from truth table. Let's say if we have A, B, C, and Y, it is let's say 0 1 1, and output is let's say 1 here, and another is 0 1 0. Output is let's say Z. So our output Y is BC plus, well, write properly, A bar BC plus A bar B C bar Z. You always multiply the output also. So when you are writing this, it is understood that output 1 is multiplied. So two of the terms in output of Y would be this. Is it getting clear that we multiply this output, whatever it is?
Yes, sir. Sir, you can multiply it in every K-map where you find it.
Yes, you can. So by default it is 1. So when we are multiplying 1 in A bar
Okay,
BC,
sir.
it makes no sense, right? Like it is understood.
Here D is given, that's why you have to multiply.
Yes, yes.
Okay.
Okay, so actually I have to go now. If you have any other questions, you can email me and I'll try to answer them. Okay. Or you can may just check if they're in the videos. Please see the video. If they are not, just comment on that video and the question you want, and I'll prepare a solution and
So, can you please share your email?
email. Okay, sure. I think it is in the title slide. This. You can also just comment on the or email me whatever you want. You can comment on the video or email, whatever you prefer.
Yes, sir. We can only share it by email, or I may have any WhatsApp or any other platform.
You email me first, then I'll see to
Okay.
it.
Okay, sir. Take.
Okay,
Thank you. Thank you.
no problem.